about impulse momentum. I used to make my kids calculate this. I'm not this year. When you design your egg drop, what you're really thinking about is impulse momentum. So impulse momentum is when we take that equation for force out of a collision, that the force is equal to the change in momentum over the change in time, we can rearrange it to look at the initial velocity and the final velocity. So this is sounding remarkably like those kinetic energy problems, isn't it? We're not going to test on these. We're not going to test on these. But we can look at the force over time as the velocity changes. That force times delta t is called the impulse momentum. Or impulse force, I'm sorry. Impulse force for time interval t. That's what you want to change with your egg. You want to change the impulse force. It's that initial shock of force when something gets stopped. Okay? The other way to think about this one is, how many of you have been in the car not paying attention when somebody else hits the brakes hard? Brake check. Okay. So, if someone comes to a nice, calm stop, do you go flying forward? No. Somebody hits the brakes hard, deer runs out in front of them, or they're just being a jerk, you go forward. Deer, right. Or a Sasquatch, depending on which Columbiana County teenager you are. We're, again, looking at the time over which that change in velocity occurs. So you know this intuitively. You all know this intuitively. And I want you to be aware that there is math connected to it. Okay?
If there's one Bigfoot, there's more than one.
Okay. You can look at sample problem 6b, but we're... Yeah. Okay. Stopping distance. This is where we will stop for today. So, how many of you have ever... Ooh, I know somebody in here who's driven a truck with a trailer attached with equipment on it, I bet.
Oh. Just behind.
Number two? Calling number two? Calling number two? You ever driven a truck with a trailer with equipment on it? Yes. Yes. Okay, good. You ever driven something a little bit lighter than that? Like even just the truck unloaded?
Yeah.
Okay. What happens when you try to stop when you've got heavy equipment on the back of a vehicle?
Doesn't work.
It takes you a lot more planning, doesn't it?
Yes.
Yes.
Distance.
Because you have a much heavier vehicle now that you're stopping. It's heavier, therefore it's got more what? More momentum. More momentum
More mass.
means that, yeah, it's got more mass, and therefore it's got more momentum because, remember, momentum is a property of mass times velocity. So you've got a lot more momentum because you've got more mass. Because you have more mass, to stop in the same amount of time requires more force. You understand there's a physical limit to the force that your brakes can put out. There is a physical upper limit to how much force the brakes can exert on the wheels to stop them. So at that maximum amount of force, with a much larger mass, it's going to take significantly more time to stop. Same thing goes if you're accustomed to driving a little Honda Civic or some kind of small car, and you get into a very large vehicle. You have to think accordingly about stopping distances because they are different. So that's the big thing. Okay.